Well, I'm Jay Simpkins, and I'm from Simtec UK, and we're an auto electrical company. We've been going for about 22 years, longer really, but as Simtec for about 22 years. And we started in the just as auto electricians, but because we had acquaintances and we used to do a lot of racing, we started sort of modifying harnesses for people and doing bits and pieces like that, and slowly but surely over the last few years we've built it up into the business we've got now, which is based in three parts really. One is building wiring harnesses and supplying parts for wiring harnesses, and two is designing the electronics which help us build the wiring harnesses and help people to get better functionality from their cars. And then the other side is the part sales, where we sell all the bits and pieces and supply information and knowledge to people so they can do their own wiring and their own harnesses with or without our products, but just so they can sit down and come up with their own great designs really.
So your background before Simtec, you mentioned you were into racing and rallying. Is that?
Yeah, I've been a bit of a motor vehicle person from very young. So I was very lucky. My father had friends who used to go-kart race, and when I was about 7, they gave us an old chassis. And my father was an engineer, an aero engineer, and he built a go-kart for me with a Honda C50 Chicken Chaser engine. But the interesting thing was that he couldn't get it to start, and I sussed the wiring at about 8 years old. I realised how it was meant to work, but I pursued an engineering career. Initially I became HND mechanical engineer and worked in a factory as a factory engineer, but I was always interested in the wiring, and we were always racing. So we had rally cars and we used to do hill climbing and sprinting, and I was the youngest president of Nodale Car Club, which was one of the bigger car clubs in the country, and through that I was always helping friends build rally cars and build wiring, but I was always more interested. I can do the engineering side, but I was always more interested in the wiring. And then we moved on, and we had a bit of a team in Rochdale where we did the Skoda Cup and Cosworth racing and that sort of thing. And I'm very, very lucky because I'm very enthusiastic about all the motorsports and motor vehicles. So we've done everything from hill climbing and sprinting to rallying to drag racing. We actually did a wiring system and provided an ECU and some work on a tractor puller. We did the first British common rail diesel tractor puller, right, with a fully programmable aftermarket ECU, and we did I'm not a mapper, but I got it set up and running. And with tractor pulling, there's no real mapping in it. You put lots of fuel in and hope that it goes. So with another friend of ours who's into diesel engines, he made all the suggestions. So yeah, I've been very lucky to be involved in that, and with building harnesses for all these different vehicles, it's meant that we've had to adapt what we do with the harness design, and we've had to create electronics. I had to start my first introduction into the electronics because I didn't do electronics as part of my courses. I've had to learn it myself and understand it and get quite into it. When we used to do the Practicality wiring looms for Bowler, and the interesting one there is we were quite successful as a company because he was very successful. I think one year there were 27 bowlers on there, all with our wiring looms on. But we had certain rules to go through, and you were only allowed 2 wheel speed sensors. So the original gearbox speedo pickup, and then an additional one for the Terra Trip. But most of the teams wanted 2 Terra Trips, and then they had a road map, which is they have like a rolling road map, so when you're out in the desert you know where you are. And then they have a security system, a safety system, that if you crash, warns the organisers that you've had an accident. And that has this is before GPS, of course, or around the start of GPS. That has a wheel speed sensor, but you're only allowed 2 wheel speed sensors. So the first bit of electronics I ever did was a little box that split the signal up and gave you all the outputs you needed from 1 wheel speed pickup. It wasn't, it was only so you could have all the equipment, you see. So that was my first bit of electronics. And then we wanted some electronics where the navigator could have a hand control that would work the wipers and the washers and the lights, but the driver also had his set of controls. So having 2 switches for some things works easily, just 2 powers and off you go. But things like wipers, you can't just feed alive to the wipers and expect them to work. So we created a little electronic box that gave you the ability to have multiple switches without anything short-circuiting.
And I already hear the whirring cogs of kit car owners saying, I could use that.
Yeah. Well, that was our first thing. The second thing we did was an indicator controller. So it's a bit, I think, blink, stop, do one. We've had that for about 20 odd years now. That was the second thing we did, again, so you could have momentary buttons, just press it once and it would set off and do indicators without you having to remember to. The other thing is, a race car, the column stalks, you don't have a self cancel and all this sort of thing. So we created that electronics, and that sold quite well for many years. Not in the kit car market, it was for the race market. And the same with the wiper motor, the wiper controller. It was a momentary push, and toggle through the speeds. But then, because we've been into so many things, we were asked to build a harness for a kit car, so we've incorporated that into it and all this sort of thing. And as time's passed, donor vehicles for the kit car market have become more. It was all right with a Ford Sierra. Very old-fashioned wiring loom, fuses, relays, and stalks and column switches and things that take the full load and power.
Yeah.
But now, even when you sort of got to Corsa C, which is only, well, I suppose time's passing very quickly now, isn't it? But that's 2002, 2003. There's only 3 wires to the column stalks because they control a body module. But people like to use that column because it's got an electric motor in it. So if you want to use those stalks, you can't just connect the lights to it. It just doesn't work. So we created a module for that. And as time's gone on, trying to give the customer all the things he finds in his normal road car, because that's an interesting one, that a lot of people, you want to build a kit car, a 7, a Locust or whatever, and you want it to be sporty, but you're so used to getting in your road car and it just does that. It just works.
Yeah.
It just, you just touch the indicator once and it does 3 or 4 flashes. And whilst you want the car because it's sporty, or because if it's a enclosed car or whatever, you want it because it's got the nice interior, you've got your leather, and you do a beautiful car for yourself, you still then go, why can't I just press this button once to start the engine?
Yeah.
Why when I walk up to it do I have to put a key in the door? I don't do that with my Focus. I just press a button. So we've developed the electronics, so you get the OEM effect, if you will.
Yeah.
You get,
and that's all done now in this body logic.
all in this box.
Yeah.
So this is the smallest. So obviously there's a whole range of kit cars from people who are doing Lamborghini replicas or whatever. And we have a complete range of sizes. So each one just does more and more and more. So this one was aimed at the sort of the 7 style car, the basic cars. But even this has sort of expanded because we've now moved on to controlling the handbrake. We'd done that a long time ago. About 6 years ago, we developed the controller for high-spec brakes. So their electric handbrake, we did the electronics for that. And then we're very, very lucky. I'll touch wood. We're very lucky. We do work for some of the supercar manufacturers, like the BAC Mono, and we've had to develop some quite complicated software and electronics for that car, and the handbrake was one of the earliest ones. But of course, so you think of that as an OEM function, and you think it as a supercar function. But if you're in a a 7 and you've got a handbrake that you bash your elbow on all the time, changing it to something like that means you've got more room in the cab, and it's easier. It's not a case of it being posh or anything. It's practicality in some things. You know, I'm trying to think which car it was now. One of the cars had the handbrake under the dashboard. You pulled it down from under a dashboard.
Yeah, Citroen 2CV had one like that.
Yeah, absolutely. And you know, brilliant, great bit of mechanical engineering there, but not very practical. I tell you actually who had it. No, I can't tell you because I can't think of the name. But yeah, so some of the stuff we do looks like it's very posh, and you know, oh, well, you know, that's only for posh cars. But when you're building a kit car, you've got to think about how much effort you're going to put in. You want to be building it not necessarily as quick as you can. You're building it because you enjoy building it. Yeah. But certain things, if you're having to run lots of cables for a handbrake, I'll just use that as an example. You know, if you've got to run a cable from each wheel and then make a balance point and then have another one going forward to the handbrake lever, if you can take a pair of calipers off a Volkswagen Golf and put them on your rear discs, then you've got no cables, no linkages, no pivot points, no mountings. There's two connectors, one on each, 2 wires to the control module, and there's your electric handbrake sorted. Yeah. And of course, everything we've done has always been done so when you take that vehicle to IVA, it passes IVA. So everything's incorporated. The fog lights, you know, how you control the fog light against headlight,
all the basic stuff that's important. Yeah.
Absolutely. And of course, because we've always been asked to build full wiring looms, or we create full wiring looms for production runs and that sort of thing, we've incorporated everything. So we control the fuel pump. I mean, I say we control, obviously the engine ECU is in charge of things, but whatever engine ECU you use, you always end up with relays to run the fuel pump, the cooling fans. All those relays are in the box. Yeah. So the ECU can either send switch signals to it to switch those on, or we've got CAN bus. Yeah. And I mean, that's a dark art. That's
the other thing people forget with a modern engine with an ECU, which is a brilliant piece of kit. The ECU is used to sending messages around the car to different sensors, and your box actually replaces the feed for that, so that it can contact your box, and it gets the information that it requires through your box.
Yeah.
That it would have got through all the sensors throughout a more complicated car.
Yes.
That aren't necessarily needed in a simple car. Your box makes sure that the ECU actually has the information it needs.
That's right. Well, whether you're using an original ECU from the vehicle, which of course at one point was quite hard to do, but nowadays there's a lot of people who will bypass immobilizers and that sort of thing, you still do need a lot of other interaction with the vehicle systems. The ECUs will expect to ask for power to be put on, so you don't just, years ago you'd put a live to the coil or a live to a solenoid valve or something like that, and that would be enough. Now the ECUs wake up in a very specific way, and you power them up with an ignition, and then they go off and say, oh, I've done all my housekeeping, can I have the injector feed on now and the ignition coil feed on now? And it'll talk to the body module, and then, which it does in the original vehicle, and we can put that on. What we've made sure we do is that a lot of body modules, particularly in things like Volkswagens and BMWs, but it applies to Fords, even earlier stuff, they're coded to the system, so you can't take it off and put it somewhere else. You've got to program it on. What ours is definitely not coded to any vehicle, so you buy it from us, and you'll do the job you want it to do. And one thing that's really difficult to describe to people is this sort of technology has been used in racing for a long time, and they call them PDMs, power distribution modules, and this is a PDM. But PDMs are only really replacing fuses and relays. You have to write all your own algorithms and everything to make things work, and some of it's easy.
So for a simpleton like me, that's essentially your fuse box as well?
That's your fuses, relays, and your intelligence. So your
It's smarter than I am.
so I mean, an example would be a heated front screen.
Yeah.
You'd have a power relay, and you usually have a timer relay, or you have a really big one that's a power and timer relay incorporated. So in there is the power relays for the heated screen, but also the timers. But we do stuff like, we automatically do stuff like, if you've got a heated screen, when you go to crank, if you put it on and you go to crank, it turns the heated screen off while the engine starts, and then when the engine's running, it'll put it back on.
That's another thing that's becoming more popular, is fitting a heated front screen
Yes.
to a car that the original Loom wouldn't have had. For example, on my car, it's a Fiesta, people are fitting those heated screens, and with me designing a new dashboard, that would be a good idea in case I cock up my venting design.
Yes. Yeah, well, you see, it's one of those, isn't it? Part of the IVA, if you have to go through it, you have to have a demister. Now, in a 7, you can probably squeeze a fan in, but people then don't want to do all the plumbing for that. So there are a number of very good companies who do the heating elements and things, but then you've got to control them. And the truth of the matter is, even the low power ones draw 10 or 15 amps, and you don't want to leave that on all the time, especially if in the broad daylight and you're having fun, you forget to switch it off. Why waste all your power and your energy? So we do them on timers, we can adjust the timers and that sort of thing. So yeah, everything we've ever done is about is always driven by what we, building a harness and how to make the harness simpler, how to make it easier to fit, and how to let the customer have all the functions he could dream of, sort of thing. And that's in a way the difference between a PDM and a BCU. PDMs are programmable power distribution modules, and you have to write all the software yourself, or all the algorithms for switching stuff on. With the BCU, we've already done that. We've already thought about it, what it's connected to. In a PDM, you just randomly choose your input, not necessarily randomly, but you choose what inputs and outputs you want to use, and you tell them what they're going to be. With the BCU, we say, this is your left indicator, this is your right indicator, this is your dip beam, this is your main beam, and that sort of thing.
And what you've got here is a board, which is basically the layout of a car. Do you want to talk us through this?
Yeah.
Because that will actually explain to people how the body logic unit works.
Well, this was exactly for this sort of scenario, really. We created what is a car. Is everything that's on this is what you might have on a 7. And we started at the back with a fog light and a reverse light and a number plate light, indicators and brake lights. And we've got these for interior lights. We're using them because it's useful to light up the... a recent development was adding the electric handbrake motor. Now, I can't show it working because it's just screwed to the board, but that's a linear actuator to pull on the handbrake cable. And there's your fuel pump. And then you work forward to, that's a crash switch. You don't have to use it, but we particularly incorporate that in our systems because it's a requirement for European vehicles, but it's quite a good safety feature. They don't go off by accident, and if you do have a crash, it'll turn all the power off to the things like the fuel pump and your engine, and it'll put the hazard lights on. If I really whack it hard, the hazard lights will come on. And then so you've got a brake switch, clutch switch. It's a little bit of a pet hate of mine. It's being able to start the car in gear. So we've got a couple of inputs on that mean that you've either got to have your foot on the clutch, it in neutral, depending on what switches you've got or what gearboxes you use, because I've seen a number of people start cars up. We actually went to a customer the other day and he was demonstrating something for us. We built a harness for him, but they'd used a PDM and they hadn't programmed in any safety features, and we pressed the start button and the car, they'd left it in gear and it promptly drove off across the workshop, which scared everybody to death. So we make sure that that's all standard. You can turn it off if you really don't want it, but it's in there, and then you can't have you have an accident. And then we control the starter motor, wipers. Unfortunately, we nicked the washer pump. The pump is missing because we stole it for a project upstairs, and I forgot all about that. And so it is literally wired up. These wires, I know they poke through the board, but they just loop round to the back of the lights.
Yeah.
So this is your wiring loom that you would have in, I don't know, a 7.
Yeah.
You know, a 7 with a windscreen and windscreen wipers. And then we move forward to, we do the DRLs. So we do the if your DRLs are within 50 millimeters of your indicators, they must turn off when you put your indicators on. So when your indicators come on, we turn the DRL off on the side. Then it's flashing, and we always give a little pair of extra spotlights. We always have an output that's customer configurable, so they can have some spotlights. And then the cooling fans and dip and main beam. So the unit controls absolutely all of the chassis electrics. So
what happens if you have an older engine which has an old thermostat switch for the fans? You just leave that as a
well, yeah, we can do 2 or 3 things. If you've got I mean, that's an interesting question because it goes over to some other subjects as well. If you've got a much older vehicle, or a vehicle where you want it to be more classic and retro, i.e. it's on carburetors and a mechanical, you know, but you want an electric fan on, but you've got no high current switching thermostat, there is ignition and permanent outputs from here that you can run those systems with, or we have a couple of spare analog inputs which are measurements of voltage, and you can put a thermostat, a temperature sensor like you would have for your water gauge,
yeah.
Or you can tap into the one for your gauge, and the BCU can be programmed to read that, and you can set the point at which it puts the cooling fans on, so it can actually deal with running the cooling fans all by itself if you're on an older conversion or vehicle or whatever, or you're upgrading a very old system. And the same with the fuel pump. If you've gone carburetors but you want to get rid of your mechanical lift pump and you're going to a click type or a rotary type, we can run the fuel pump but based on engine RPM and ignition and things like that. So you still incorporate because that's an interesting one, that if you've got an external click type fuel pump or an electric one on a carburetted setup, at IVA it's still not allowed to run if the engine isn't running. So you can't have them sit there going click 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 anymore. That those days have gone. They've got to, for safety, they've got to
switch.
Yeah, they've got to turn off when the engine isn't running or when the car crashes. So there's your crash switch for killing the fuel pump. But we take in the engine RPM, and if the engine isn't running, we don't run the fuel pump. So it can either be completely commanded by the engine's ECU if it's that type of system, and if it's an earlier type of system, we can take control of these things and bring their functionality up to date.
Exactly. So basically, it's a very simple way of updating an existing older car to modern safety standards and latest developments, if you like, in for example, the daylight running lights.
Yes.
For example, which is something that is a relatively recent phenomenon, and donor cars are on the cusp.
Yes.
Of between pre-daylight running lights and post. It was something that was. Volvo were ahead of the world.
They're very much so. Yeah. So I mean, when we were just auto electricians and we used to do specialist work for the local garages, I remember working on Volvo lighting, and the number of people who hated the fact that the lights were on all the time, and now it's expected and people are so used to it.
It's ruined my piss taking out of my Swedish friends. Eventually, that they can actually say we were just ahead of the game, and I've lost that argument now completely.
Yes. Yeah. No. And I was always one who used to hate it. And funny enough, now I'm obsessed about, even in the daylight, turning my headlights on. Yeah, because the truth of the matter is, you are seeing better. It's as simple as that. And perhaps it's old age. I'm getting into my mid-50s. When I was 17, it was all about driving fast and sillily. And now it's all about, not really all about being safe, but, safety starts to come into the back of the mind, doesn't it?
Absolutely. And you've even got a position there for the clock. I think that's one of the things that sometimes is definitely an afterthought, and it's I'll spin a couple of wires from this to something.
Well, what we hope we've done is, again, it all comes back to being asked to build wiring looms from everything from basic kit cars all the way up to some of the supercars we do, and through to even some of the industrial applications, because we do some electrical systems for diesel underground vehicles, believe it or not. And every time they have a specialism and they want something special, we think about it and we try to incorporate it in our electronics. So yeah, we've got, all our body modules have spare outputs, permanent live for a PowerPoint, and a permanent live for a charge point, USB, because again, so another one nobody thinks about, but you buy your Caterham 7 and you think, that's brilliant, that's what I want, it's going to be really basic, until you get in and you go, oh, where do I put my phone and how do I charge it? Well, in my Focus, I just plug it in there. We borrowed a transit van to go to a show the other day, and lo and behold, it's got about 5 USB points in it, because everybody's used to charging their phone and their PDAs and all the rest of it. So yeah, even the basic model has outputs for all those sorts of things.
Right, as somebody who understands wiring but is scared of it, and a lot of us are, they buy your Body Logic box and it has the plugs that plug into it. How do you explain the different connections and what goes to where, and if someone's creating their own loom, do you have like an instruction book that explains this must be for this? Don't plug in your lights into this one because you'll end up
we've worked quite hard on that, and we've probably, I think I mentioned earlier, we've had to upgrade a lot of our hardware because of the world shortage of electronic components, which has allowed us to bring in new features, but it has put our paperwork back a little bit. However, no, if you buy any of the range of the body modules, we have 2 or 3 things to help you. So the first thing we have is an Excel spreadsheet that tells you the pin numbers on each of the connectors, and it gives you a wire color. So we do a color code system based on the old Lucas color code system.
Yours works.
Yeah. Not Lucas Prince of Darkness. We have avoided that one. So yeah, we use the Land Rover. I mean, again, we used to do these Paris-Dakar cars for Bowler Company, and they were very, very keen to keep absolutely true to Land Rover colours, because anybody who knew about a Defender would know how to fix it, and we've stuck very much to that. So indicator left is green red and indicator right is green white. So we have this spreadsheet and it gives you the wire colors. It then tells you what it does, so it's dip beam left or indicator left or whatever, and then it says where it would go to. It gives you a little description. Some of my paperwork, which I need to perfect really, but some of it actually tells you that it's alive when the ignition is on or when the side light switch is on, and so you sort of understand what it does. And then what we do have is a complete set of sort of drawings where I've depicted how it's connected. So I've got a line drawing, a stick drawing, or if you want to call it, but we show the body module. And it's broken down into all the different circuits. So side lights, head dip beam, main beam. Each page is dedicated to one thing, so you don't get too much information at once. All the way through to how the electric handbrake's connected, if that's what you have on that system. And it's a line drawing, and it tells you the colour that we're using, the pin number we're using, which pin you should connect to. To the motor. Of course, some of it has to be assumed because we're working there on a Land Rover wiper motor, but you might be on a Ford or a Vauxhall or a BMW even, that sort of information as well. We have quite an archive of connectors and connections and that sort of thing, so people can phone us and ask us. We're just upgrading our website. We've been lucky to have had a website since almost the invention of the website in its sort of modern format, so 18 years or whatever, and ours is getting a bit a bit dated, and we're just about to launch somewhere around late December, early January, a new website, and there's going to be a whole sort of a wiki on there where we're going to be putting in a lot of the connectors. So if you want a BMW one, I've got how you pin up a BMW one, and because the interesting thing is not all wiper motors work the same, especially if you've got a Honda or a foreign car like that.
And the next stupid question, or it might not seem stupid, but can you supply the wires in the colours that you described, so that you can actually supply the wires so that when people are using your colour code, they've got exactly the right wires?
Absolutely. As well? We can literally, if somebody is wanting to build 3 or 4 cars and they just want the body module, we can sell that. If somebody wants the body module with the connectors because they want to do all their own wire colour and create their own system, which is really, I enjoy that sort of thing. So if somebody's in that mode, absolutely, they can have the connectors. But what we also do is that we just supply it as what we call a tails kit. So that is the connectors where we've pinned the wires in at the wire gauges that we would use. And this is all modern, absolutely up-to-date, British-made automotive spec wiring. It's what you'll find if you open up your loom in your BMW Mini or something like that. Thin wall, oxygen-free copper cable, and we make the connectors up with 4 meter tails. What we tend to do is sort of 2 meter tails for stuff that would be in the dashboard area, so warning lights and ignition triggers and this sort of thing, switch triggers, and then for your consumers, that's what we call lights, motors, anything else. We do 4 meters. So this whole board was created that way. We put together our tails kits, we plugged it in, we put some little cable tie bases where we wanted to run the wires, and we spent a couple of days, 2 of us, and obviously we spent a lot of time because we wanted it, being a bit anal, we wanted to get all the greens going green in a nice striped line. But so you can lay the harness out yourself like that, and this sort of thing here isn't a cheat, because that disappears off into these plugs here, into that multi, and goes over to our steering column and switch stand there, which is a bit tatty at the moment because it's come back from a show sort of thing. But so that sort of shows where you go off to your that would be your dashboard, and then this is the rest of your car going through your bulkhead, through your transmission tunnel, out to the back of the car, and up forward out to the front of the car. So it really is a real depiction of a car laid out on a board. So we can supply the wires that way. And if you really want to if you want to do your own harness and you want to use a completely different colour code, a Ford colour code or a BMW one, we have about 8 tons of wire upstairs in every size and in every colour you could imagine. And we did some wiring for a company recently who wanted to use an American colour scheme, and they're a bit obsessed with beiges and deep. They have light.
You're telling all red looms.
Yes, I've had plenty of experience with those.
For a male
yes, absolutely. We used to do some work on. We have a big quarry up here, and we used to do some work on the tipper lads when we first started, and Renault trucks and Volvo trucks all white, with printed numbers on the cable, so you know it. And of course trucks run on diesel, and diesel dissolves the ink. So finding wires when they're not coloured is not the best. But if you want to create your own colour scheme, you ask us what wire colours you want, and we've got it. And if we haven't, we can have it made, because I say we did this job for this American one, and we had some beiges and some purples made, and we actually, and this is a serious one, we actually had a customer who was making a harness for a custom car, and they wanted specific colours, and they came to us with a colour chart. And the company we work with in the Midlands who make the wire, they made wire to a colour chart. Never seen it, no, probably never do it ever again, but
having done work with the custom car world, I can actually believe that. That doesn't surprise me at all. They're all absolutely, down to the smallest detail.
Absolutely. So we always build our harnesses to a specific scheme. So whether it's the little Logic 1 or the big Logic 24H, which is very powerful, we stick to the same colours for everything.
So would it be better if someone's starting a project and they're building, say, a Stratos replica or a Caterham 7 type car, would it be better if they called you and said, well, I'm doing this kind of car, which is the best box for what I'm doing? And then the conversation goes from there, or
yeah, no, absolutely. We're very happy to speak to people, and I'm about, and this might sound cheesy, but I'm about technology and the wiring and the things. So I won't say you want this because it's that much money if you can have the smaller model, or
yeah.
I will, if somebody tells me what they're building and what they want to achieve, I will help them as, that's it. We designed these so we could speed up building the wiring looms for the bowler cars, because in the bowler cars, when they were doing nearly 30 cars a year, and we had a team that were building them, and we used to spend 3 days just doing the fuse box. And I'm a bit obsessed with safety, so every single circuit's fused. So, you know, dip beam left has a fuse in there, dip beam right has a fuse in there. So if you have something fail, then you know if that light goes out, you know it's only that circuit. But when you do that in a fuse box style like we did on the bowlers, which was perfect for them for the rally, because if you're out in a rally and something fails, you want to instantly go to it. You don't want to go, this fuse does 10 different things, which of the 10 that has failed has taken out all these things. You want to go, that fuse does that. But it meant that we had a fuse box, a massive fuse box. It was 4 16-way fuses, and then there was 4 sets of relays, 2 7-ways and 2 4-ways. Now we squeeze all that into this.
What happens if one of the fuses goes with your box?
Well, we use 2 types of fusing in these. We use electronic fusing, so smart fusing, smart FETs.
So
which
like
they monitor the current. So the processor drives the switch on and off, and then it monitors how much power is going over it. And they're particularly used for things like the indicators. Yeah. Because one of the smart features we've got is that you can have any combination of LEDs, incandescent bulbs, electroluminescence, like Citroen use on one of their models of cars. You put all the lights on, and you can teach it what the current draw is of the indicators.
Exactly, because your LEDs are going to be completely different.
Absolutely,
so your old bulbs,
absolutely. Yeah. And because you can teach it the current draw, it then does a bit of maths on it, and you still have your bulb outage. So you can later on, you could go back to incandescent bulbs because you didn't like the look of the LEDs, and you can just reprogram it and say, and you just go into a learn mode and you press the button and it goes, switches them on, measures the current, does some maths on it, and then you've instantly got your setup. So we use the smart FETs for those circuits, but FETs themselves create quite a lot of heat, and it's a problem with PDMs. Not a problem, but with PDMs they can get quite hot, and you'll always find them in fancy aluminium boxes, and that's as much about the look as it is actually about it. Sorry, it's about the look, but it's more about dissipating the heat, because FETs, transistor type switches create a lot of heat. So for other circuits we use relays. So for big heavy current draw like cooling fans, fuel pump, starter motor circuit, we use relays, and we use a thing called a polyfuse. And if you're into pulling things apart, if you ever find a BCU out of a BMW or a Ford, open it up and there'll be rows of them. And they're a funny little device. They're basically 2 bits of metal glued together with a glue that's, when you've a fixed current flow across them, it's just a glue. And then when it reaches a certain current level, the ampage threshold, it converts to a resistance. Or it isn't a glue, it's a compound, no resistance at all, and then it goes to this sort of not infinite resistance. They get warm to the touch. They're not a thermal fuse. They are a chemical fuse. When you fix the fault, you stop the power flowing into that circuit, i.e. you turn the wipers off or the headlight off, turn the power back on, and the chemical is reversed, and it just goes back to normal. And they have a maximum number of cycles, but it's 1,000 cycles or something like that. So unless you're really unlucky, they're never going to go faulty. Although we can service and replace them. But the interesting side effect of them is that because they're a resistor, they will carry on passing a voltage. It doesn't pass current, it passes a voltage. And that means that if you've got, say you've trapped a wire here, and it's got trapped with a bolt or rubbed through, if you buy one of these power probes with the little LED testers, because the fuse still passes a voltage, there's a volt drop. No matter how good your wiring is, there's always a volt drop from, an ordinary piece of cable is 0.006 ohms per meter. So between here and here, the voltage goes from 12 volts to 0 volts. And if you get a power probe, you can actually, not that you'd want to pierce the wiring, but if you're going through connectors, you can probe at each of the connectors and you will see the voltage disappear. And to the point where, and at the other side it'll all be green because that's earth, and this side it'll be green, not so green, red to bright red. And it's an interesting, completely flips how you do diagnostics on your head. Although the whole concept of the body module flips diagnostics because the thing people always say to me about it is, well, where's the fuse? If a fuse blows, I know it's the fuse, and I go, well, it isn't the fuse that's faulty. It's something else. Fuses, they don't sit there and go, I'm going to go faulty. They don't just blow. They are the symptom. They're not the cause.
Yeah.
So, yes, you can't see that circuit has blown.
I see them as warnings.
Yes.
The fuse is the warning that you've got something not working.
That's it. Absolutely. So, because we do our very best to fuse everything individually, if the headlights come on, that one comes on but that one doesn't, it's that circuit that's faulty because it's that fuse that's tripped. And then you can start going, and I always say when we do little courses on how to do wiring, never assume anything and always start with the consumer.
Yeah.
Because the chances are it's a blown bulb, not a faulty wire.
Yeah.
But if you start with the bulb and then the holder and then the next connector and then work back, you're more likely to find it than you are going, I'll put a new fuse in. And of course that used to be the one. And while you've got a real blade fuse in there, we've had this on the Practicality, fuel pump seizing up because it got dirt in it and blew the fuse. Oh, it's the fuse, we'll put a 20 amp. Oh, it's okay, car gets going again, does a few 100 yards and it blows the 20 amp. Oh, we'll put a 30 amp, Eventually they put a 40 amp and set the loom on fire because at the end of the day, it wasn't the wiring loom, it was the pump, and all it did was draw more and more current until it melted the wires. And that's, well, it's the fuse that's faulty. No. The fuse is warning you there is a fault on the system.
I was thinking it as a nerve. The wiring is a nerve.
Yeah.
When you get a prick in your finger's not hurting. It's your brain telling you that your finger's hurting, and it's the nerve that carries that signal to your brain.
Yeah.
And if that, and basically your fuse is the pain receptor in your brain going, yeah, something's not right here. That's hurting.
yeah, absolutely. So it feels a bit bizarre that you can't see a fuse to see what's blown.
Well, I love that.
What you've got to, when you're doing diagnostics or you're broken down at the side of the road, you've got to just think about it a bit differently, a bit in a different way, come from it from a different angle, go, right, okay, that isn't working. Let's start with what isn't working and work back towards the control unit, especially with things like lights, because if one headlight's out but the other isn't, this is doing its job. If you're into the idea of digital dashes and things like this, especially AIM or that sort of system, you can interrogate this. And in fact, not in the smaller model, but in our 24, because we supply them to a couple of the low volume vehicle manufacturers who are now trying to get European, following the Brexit thing, they're now trying to get European type approval opposed to IVA approval. They actually have to have OBD compliance. So our bigger module is OBD compliant. So you can plug in a generic Sealy, Duratool scan tool and ask it. You don't so much ask it as it just spills out a P code system and says that this fuse has tripped or that fuse has tripped. But what you can do, with a really good digital dash, a GEMS or an AIM or something like that, you can, if you've got the time to write the algorithms yourself in the dashboard, this spills out all the data that, you know, when you switch the switch over there, it's an earth trigger to here, and the unit goes, oh, he's put the side lights on, and it goes off and says, am I allowed to put the side lights on at the moment? Now, you're always allowed to put the side lights on, but headlights, of course, you're not always allowed to put them on.
Especially not on high beam.
That's it. So when you put that switch on, it goes, am I allowed to put the headlights on? So it goes, well, is the side lights on? Yes. Have we got enough battery power? Yes. So on and so forth, until it puts them on. So the data that's exported from that, you can see.
It takes a fraction of a second.
Oh, microseconds! Absolutely, it takes microseconds to happen. In fact, the processor, if it was an athlete, it would be walking like an old person. The processor in there, it runs very fast, but it's doing very little work really for what it's able to do. So we have to do a lot of sampling switches, because believe it or not, the human body is very sensitive. If you press a momentary switch or tap a key on a keyboard, if it doesn't react within 25 milliseconds, the human brain knows it's not reacted. Yet the mechanical bounce in a mechanical switch can be anywhere from 10 to 30 milliseconds. So we have to make sure that when you press the switch and it bounces, and you think that press is a nice good on off, it isn't. If you had an oscilloscope on that, it'd be on off, and it peters down as the contacts bounce, and we have to filter that out. We have to be very careful that we filter it long enough, but not so long you go, why is it not working? On off. You can do that. Press it on. No, press it again. Oh no, and it's going on off. But the point of that ramble is that that sort of information can come out of the BCU, and you can use it on a dashboard, so you know you've switched the switch, and you know that it's tripped that fuse, so you know that the switch has been pressed, it's not the switch that's faulty. Or maybe you switch the switch and the BCU doesn't see it, and you go, well, then it's the switch circuit that's faulty. So
now to the crux question. Starting, because obviously sky's the limit. Starting with the basic unit, what sort of price are people talking about?
So for the very basic unit, we're pricing them, I think it's 480 quid for the base model. And we have in the range, we have a Logic 1, a Logic 10 and a Logic 24, and then the really powerful one for your fancy kit cars, your Ferrari replicas, and your I'm trying to think, it doesn't matter. They all overlap. So there's a base model 10 that comes in just below the top model Logic 1, and so I think the accurate figures are on the website. Jin, my wife who runs the business, she's the interface with a lot of customers as well, because she likes to make sure that customers know what they're getting. We're supplying the customer with what they want. I'm a bit more ethereal and go off, I can do this and we'll design this, and she's a bit more, this is what do you want and this is what you'll get, but the base price is there, and then we move up to about 600 quid for the unit that does the electric handbrake, and the wipers and wash and all sorts of stuff like that. And then the 10 overlaps that, and the 10 has more outputs on it. We'll do the twin caliper handbrake. It'll gives you extra power for your spotlights and extra heated rear screen, heated front screen, and that sort of thing, whereas this will only do one or the other. And then the 24, that does central door locking and again, another level of control. They all can do central door locking, but you have to run an extra relay. That's not strictly true, it depends quite which locking system you're using. So there are some anomalies. This is where I'm very happy to talk to people, because depending on the hardware that you're using on your car, it might
already be there.
It might be there and we interface with it, or you might have to use this model because this one doesn't do it, or vice versa. So we'll never say buy that because it's the dearest. We'll say, well, actually we can use the cheaper, bigger model to achieve the same goals because it has slightly different hardware. And I always make sure that the cheap, one thing that annoys me with some products you can buy on the market, you buy a unit and you pay an amount of money for it, and then you just give them extra money to input a security code that allows you to access some already there hardware. Ours work up in hardware level. So if you buy the base model, it's cheaper because it hasn't got that extra hardware. So I like to be fair like that, if you will. We're not ripping you off by telling you to buy a service key just to access what you've already purchased. That sort of thing really annoys me. So yeah, and we go right up to the 24H, which can do electric windows with anti-trap and the full central door locking, rear wipers, front, and
going through my car now, just ticking the boxes. If you've got a production car and it's got all these things on, you think.
Yeah. So and then we have a range. The range expands sideways slightly as well. So in here there are slots for what we call daughter boards. So we can do the RF. We do with the RF steering wheel system. So we can plug in a daughter board, and then all the switches can be on the RF. We can also have them so they can be either or. So you can have hardwired switches inputs and the daughter board, the RF inputs, and you can swap between the two. You can turn the lights on with one button and them off with another if you want. But that means that we've got some other smart functions. So if you've built a Caterham 7 with a paddle shifter system and you want to go to a wireless steering wheel, our daughter board here has an output on it that we have an extra hole in the side, and you can plug into that daughter board and it directly triggers ECU outputs, so your traction control or your launch control or your paddle shifts. Or you can use those outputs for triggering your central door locking and that sort of thing. And that's where you then need, so the smaller unit like this will do central door locking, but you need to have the external wires to it. They're not on this plug, whereas the top of the range has everything there already allocated and set up for. So yeah, you can stretch your budget, as you say, for anywhere from 470 quid all the way up to I think it's not quite 3,000 quid, 2,000 or something like that for the biggest unit. And then we do a whole load of sort of, which I'm not actually showing you and are not that relevant to what but we do a whole load of sort of door out stations and CAN modules. So if you're building I think I told you about the custom car we did that had more lights and running lights and heated seats and electric seats and all this, and electric steering column with memory adjust, and that was done by external CAN modules we have that allow you to expand. So if you've got one of these, if you want the lights that go down the door like they say at a Bora or something like that, we can do that with the expansion modules. We've got a door out station that deals with all that sort of stuff. But for the good old down to earth kit car builder, this particularly is a really good model range because it does pretty much everything you want, unless you're really going into some fancy stuff, Levers.
Yeah.
On our Land Rover, it's a development mule, and we've modified the floor so much I can't get the levers back in.
Yeah. So
we've replaced it's an auto.
Yeah.
And we've replaced all the linkage and levers for the gear selector and for the transfer box, which isn't on this at the moment, but it applies to an auto kit car. And we've created this controller for it, which is in a bit of a big box at the moment, but it has this little knob we've got here. So when you turn the knob, it selects the gear that you, so that's park, and then reverse and neutral. Now it's got a load of interlocks, so you've got to have your foot pressed on the brake. So it upgrades the old mechanical lever that you could put it in any gear at any speed and all this sort of dangerous nonsense. When it's dry, it picks up the road speed and when it's driving. So, but somebody came along and said, "That's brilliant. I've got a kit car. It was a Cobra, and it's all auto, but the gear lever's in the middle, and I don't want it." And so I think we sold one to them. And another guy came up. A couple of people mentioned. I never even thought about it until they mentioned it. They said, for people who are disabled who've got kit cars or Land Rovers, you can't. Even the process of an automatic moving the lever can be quite difficult. This can go on the right hand because it's only electrically connected.
Yeah.
But this knob can run the BCU. You can have the lights on it, and you do a swipe on it, and it does from a Land Rover that selects the diff lock, and that comes out of diff lock. And then if I swipe again, there's the high-low range again for a Land Rover, not for a kit car or anything. But in those screens, we can put lots of screens in, and we can work lights and wipers and everything just from one knob by swiping. But we were pleased with that. I only did it for mine because I was sick of trying to make all the levers fit and everything. I mean, the thing we love doing is getting involved with people's projects. And we can get involved with the projects from just making suggestions. Ring us up. We won't try to sell you this. We'll say, well, what about doing this? You could try that. Or we can get involved with people's development projects. If somebody's coming up wants to build a new kit car range, we can sit down and we can design harnesses to cost, to spec, to fanciness. And we've got some really nice. We've got access to some really nice tech as well. We've got. I'll show you later, but we've got a smart knob over there we use for a gearbox controller, and that can be incorporated to it. So yeah, we're all about the tech and getting the simplest but most exciting system you can have on your vehicle without it becoming too complicated.